going to continue this chapter with solving equations. This time, instead of combining like variables on one side of the equation, you're going to have variables on both sides of the equations. You're going to have to bring them together. So let me show you an example. 13 plus 5x equals 2x minus 8. Our whole goal when solving equations is to isolate the variable. You can't isolate the variable until all of the variables are on one side of the equation. So it doesn't matter if you collect the variables on the left side of the equal sign or on the right side of the equal sign. I like to keep things positive, so I'm going to move this variable to this side. Now I am moving it to the opposite side, so I am going to do the opposite. Look in front, it's positive, so I'm going to subtract. Over here I have 13, this is a positive 3x. And on the left side, I have a negative 8. Now that I have all the variables on one side, I can follow with my two-step procedures. Bring the non-variable term over. Again, it's positive, so I'm going to subtract. Same sign, sum. Opposite would be to the bottom. So x equals a negative 7. Okay. So what I did in this problem is I moved the 2x over to the left side and collected all the variables on the left side. You would get the same answer if you collect the variables on the right side. So let's try it the other way. Okay. So instead of bringing the 2x to the left side, I'm going to bring the 5x to the right side. I'm going to collect all the variables on the right side. 2 plus a negative 5 is a negative 3. Here I have 13. I'm collecting the variables on the right side, so I want to move everything else away. Bring the non-variable term over. So x equals a negative 7. Either way is the same amount of steps. Either way, you're going to get the same answer. Let's try another one. Let's try 24 minus 3m equals 5m. Now this one looks a little different than the last one. This one doesn't have two terms on the left side and two terms on the right side. When there's only one term on one side, you're going to collect the variables on that side. You can bring this 5m over, but it's going to be more steps, and I'll show you that next. So when there's only one term on one side, and it's a variable term, collect all the variables on that side. Okay, so we get 24 over here. They're multiplying, so I'm going to divide. I get m equals 3. Okay, so what happens if you don't collect the variables on the side with one term? It's still solvable, but it's going to be more work. So instead of bringing the 3m to the right side and collecting the variables on the right side, I'm going to collect the variables on the left side. This is a positive 5, so I'm going to subtract it to bring it to the other side. Same sign, sum. On the left side, I also have a 24. On the right side, the equal sign, there's nothing. So it would be 0. I'm going to bring my non-variable term over next. It's positive, always look in front, it's positive, so I'm going to subtract. So I get negative 24 on the right side of the equal sign. On the left side, I get negative 8m. And then I'm going to divide by negative 8. So m equals 3. Either way, you get the same answer, but the second way is going to take longer. Alright, your turn. Try these two problems. Try 20 plus c equals 4c minus 7. Also try 16d equals 22 plus 5d. Give those a try. Let's do problems with grouping symbols. collect the variables on one side. Again, it doesn't matter if you bring the 6z to the left or the 5z to the right. I'm going to keep things positive and bring the 5z to the right side of the equal sign. This is positive, always looking in front. This is positive, so I'm going to subtract. This would be a 1z. I'm just going to put z. It means the same thing. Over here, I'm left with the -2. Always take those signs out in front. Bring the 8 over. I get 6. Because this z is a 1z, that z is already by itself, so my answer is 6. Go ahead and try this one. 3 minus 4a equals 5 times the quantity, a minus 3. After you're done with that problem, I also want you to try this one. I know it's working with fractions. Give it your best shot. 4x minus 5 equals 1/5 times the quantity 5x plus 20. Okay. We have one more section in this, or one more part in this section. It's identifying the number of solutions of an equation. Identify the number of solutions of an equation. Okay. So you're going to learn that each equation can have one solution, which we've had in the past. Everything we've done in the past in 6th grade has always had one solution. Your equation can have many solutions or no solutions. And let me show you how you distinguish that. So let's say we have an equation like this. 5x minus 6 equals 5 times the quantity, x minus 1. Okay, so you're going to solve the equation just like we have in the past here using the distributive property. I'm going to distribute this 5 first. Eventually you're going to get enough that you can see it in this step. But I'm going to keep going here. I'm going to collect the variables on one side. Doesn't matter if you bring this 5 to the right side of the equal sign or this 5 to the left. So when I bring this over, these cancel out. Do you see how when I do 5 minus 5x, my variables cancel out? I would get 0 x's. I'm not even going to bother to write 0x because 0 times x is 0. They're gone. So I can left with -6 equals a -5. Do you see that's a false statement? They do not equal each other. When you get a false statement, that means you have no solutions to this equation. So your answer would be no solutions. Maybe you want to write a little note. You're looking for a false statement. Here's another example. 4 times the quantity, 3x plus 2, equals 2 times the quantity, 6x plus 4. Okay, so again, distributive property first. This time I have the distributive property on both sides, so I'm going to do them all in one step. 4 times 3 is 12x. 4 times 2 is 8. 2 times 6 is 12x. 2 times 4 is 8. Again, you'll look good enough where you'll see the answer in this step right here, but I'm going to keep going. I want to collect the variables on one side. So again, it doesn't matter which variable I bring to the right or the left. I'm going to bring this to the right side. These are gone. Again, you're going to notice that your x's cancel out. There are no more variables. 0x. I'm not even going to put 0x because it means 0. I have 8 on the left side of the equal sign and 8 on the right side of the equal sign. I got a true statement. When it's a true statement, that means there's going to be many solutions. There's more than one answer, more than one x equals. Okay, last example. When your variables don't cancel out, you have one solution. When you have one solution, you're going to write b equals -7 as your answer. If you get no solution or many solutions, your answer is no solution or many solutions. We're going to do more of these in class tomorrow.